Okay, in order to demonstrate this standard, I have the question: a parallel plate capacitor with plates measuring 0.5 meters by 0.25 meters. They can hold 3.2 picocoulombs when air is between them per volt of potential difference. Barium titanate dielectric slab completely fills the space and has a 6-volt battery connected to it. What is the electric field of magnitude inside the capacitor? So first of all, we have the capacitance of a parallel plate capacitor. That is the first equation here that I had written down. And then here we have capacitance in general. So what I want to do now is combine the two. So set them equal to each other. So then we will have Q over V is equal to ELA over D. Okay, and then now we can rearrange this in order to get D. So you have D equals, so that will give us, that'll give us E, and then times V divided by Q. Okay, so there's our equation that we're going to use, and now let's set up a few of our, what are they called? Some of our values here, sorry. So first of all, for A, which is here, that's going to be the area. So let's calculate that. So our values are already in meters, so we don't have to convert that. So it'd be 0.5 meters times 0.25 meters. This will give us the area of each of our plate, which will give us 0.125 meters squared. So that is A. And now, so we're going to want Q. So Q is 3.2 picocoulombs, which then we're going to want to change into regular coulombs. So that is actually going to be 3 times 2 times 10 to the negative 12, I believe, coulombs. And then we know that is going to be 8.85 times 10 to the negative 12 coulombs squared over Newton meters squared. And then for the voltage of our battery, we have V here, which is equal to 6.0 volts. Okay, now we can plug this in over here. So we have D equals 8.85, 12. And then we can multiply that times our area, which is 0.125 meters squared. And then times our voltage is 6.0 volts. And then we're left with Q, and then we know Q is 3.2 times 10 to the negative 12 coulombs. Actually, I made a mistake. I jumped ahead of myself. So the battery voltage here is this. But this is actually going to be 1 volt, I believe. So I'm plugging that in my calculator. And then that gives me a value of, let me redo this section really quickly. Alright, so that gave me D equals 0.34 0.46. And then, of course, meters here. Okay, so now we want to find the electric field. So that means we need E. So E is equal to V over D. So now we have both V, and this V is going to be the battery. So V is going to be equal to 6 volts. Yeah, 6 volts, right? Yeah, 6 volts. And then D is going to be what we had just calculated, what is going to be 0.346 meters. So then we're going to plug that in. So it's going to be E equals 6.0 volts all over 0.346 meters. Now I'm going to put that in 6. And that is going to give us 17.4 volts per meter. And that gives us the electric field for our